Oh, when did you get here? I'm sorry, I didn't hear you come in. Hi, I'm Mr. Barnes. I'm your math teacher, probably. Today we're going to talk about parts of parabolas you probably did not know existed. You know about parabolas from chapter 4, right? I know it was last year, but I'm sure you remember it. If you ever have a quadratic function, y equals x squared, it makes a parabola. In fact, that's pretty similar to what the U-shaped here, right? You even learned about them in Algebra 1. But there are some secret parts to a parabola, some not imaginary, but invisible parts to a parabola we haven't really talked about yet. And I want to start by sharing a picture of maybe a familiar image to you if you've ever been to the dish in Stanford. There are two beautiful radar dishes here, and these are, see that shape right here? It kind of takes that shape right there. Ever wonder how this works? Well, wonder right now, in case you haven't. Yeah, this is all about, like, if you're going to take something out from space, gets a signal, let's say it's a sound, let's say music from another planet. It comes down here, hits this parabolic arc, and goes right to this focal point. This is called the focus of the parabola. So what, right? So what? Well, what if we had lots of different beams? We'll say alien music. There we go, your favorite type of music. Here, bounces there. You'll get a stronger signal because no matter where this is coming from, it bounces off this parabolic mirror into this focal point. That's why there's some sort of, I can't really see it because the fidelity of the photo, but there's some sort of receiver right there, and we end up getting a lot of beams hitting that parabolic mirror into the center there over and over and over again. Now, if it was going the other way too, you could also like send a signal here. Like you could take here, have the scattering of things, then would take the opposite route, going from this emanation point or whatever, hitting this parabolic mirror, and then you could have some sort of like laser beam or something full of alien music or whatever your imagination goes for. But no matter which way you go, you're going to have these things bouncing off, and the angle of reflection and incidence will make this go to this focal point. And every parabola has a focal point. Every parabola has a focal point. So we're going to find that focal point today. But there's also something else called the directrix, which, let's see, right there. The focus and directrix is there. We're going to look at both of these things in parabolas today. And it's a little mysterious at first, but once you practice, you will get better and better and better at it. So let's turn in our notebooks to page 91, and let's talk about the features of a parabola. This is section 10.2 on page 91. That's page 91. And we're going to be starting by graphing this function right there. And don't be afraid of that fraction there. We're just going to take the x, and we're going to square it, and then multiply it by 1/8. And I could, since the domain is all real numbers, I can put anything into x. I'm going to choose numbers that are nice for x there. I'll make a little t-table off to the side here, because I think that helps. X and y. That 1/8 tends to compress that parabola towards the y-axis. So instead of getting like one of those thin U's you're probably used to, it'll be more radar dish, just like in Stanford there. If you've never had a chance to go to the Stanford dish, highly recommend it. It's a great place to run and walk, very hilly, very beautiful. It's a good place to get outside and get some sunshine. I'm a huge fan. So what should we do here? I'm going to choose numbers that will work nicely. How about we'll choose -8, -4, -2, 0, +2, +4, +8. In fact, if you would like to stop the video and populate the y column to see if you're right, I will really enjoy that, like we do in class. But if you don't want to do that, I'll never know. I just won't. You can have me do all the work. So I'm going to take -8 squared is 64. It's PEMDAS, right? We're doing exponents first. 64, 1/8 of that is, 1/8 of 64 is 8. That's totally graphable. How did I know that? If I square -4, that would be 16. 16 divided by 8, or 1/8 of 16 is 2. If I square 2, I'm sorry, if I square negative 2, same difference, right? If you square 2 or negative 2, you get the same idea, which is 4. An eighth of 4 is 1/2. I'm just going to say 0.5. This is the easy one. 1/8 of 0 is 0. And then parabolas are symmetrical. What goes up must come down in the same curve. So we are going to graph those points as much as we can. Oh, and of course, you'll see that this whole page will be taken up by a coordinate system. And below all this stuff, we're going to write some stuff about parabolas you probably didn't know. Some stuff that you need to know, but we're afraid to ask. But in the meantime, I am just graphing points the best way that I know how while I talk about it. This is, wow, 6. I kind of feel like we're missing a 6 here. I'm going to put a 6 in here as well. And I'm not going to put negative 6 because since these are symmetrical, I just copied over there. 6 squared is 36. 36 divided by 8 is, I don't know, 36. I guess 4.5? 36 divided by 8, 4.5. Good. All right, so 6, that would be 4, that would be 1/2. Is that right? Nope. I thought that was wrong. One nice thing about a parabola is because you see it so much, because if you just imagine something flying through the air, you kind of know when the shape is right and the shape is wrong, just instinctually. All these points get reflected over here. And so I'm going to be graphing the other side of this parabola here. All right, this you knew how to do. Well, you did at one point, right? If you forgot it, practice it, because that will help. Now, there are two things about this parabola we have never really talked about. Remember that radar dish? Remember all those points? They went to a single point. You remember that? Well, that point is what we call P units away. And for this one, it's going to end up being 2 units away. P equals 2. So I'm going to tell the answer for this one. You're eventually going to derive that yourself. If this were a radar dish, every line, and it has to be a horizontal line. We're assuming it's not coming in diagonally because that would do something crazy. But you have to focus, like if you've ever had DirecTV or anything, you have to like focus this towards the satellite. Otherwise, it just won't pick it up. So all the beams would go this way, parallel to each other, hit this point, and then right into the, what I guess would be the receiver there or something. Just kind of like we did on that drawing. No matter where it goes, it would bounce against the radar dish into this. And how we know that is we can calculate that using this p-value. In this case, this is the p-value, and p equals 2. We're looking for the p-value. P equals 2. I didn't tell you how to find this yet. I will tell you that soon. So don't stress, okay? How did you know it was 2? Someone asked. I just heard someone ask. I just knew for right now because I know the secret. You'll eventually know the secret. So that's called the focus of this parabola. The focus. Now, there is another invisible part of this called the directrix. And the directrix is P units away from the vertex. Remember, this is the vertex. Vertex is like the elbow of the parabola. If this were upside down, it would be where what goes up must come down. That's at the vertex. This one is what goes down must come up. So this is like the middle part of the parabola. And if the focus is 2 units this way, the directrix is going to be 2 units this way. So this is, if this is 2, this is 2. And the directrix is an invisible line. Here, I'm going to use my straight edge. You knew I was going to do that, probably. Don't travel anywhere without your straight edge, people. You never know. This here is called the directrix, which is one of the more fun words to say in this class. And the directrix in this particular case is the line y equals -2. And the directrix is always p units away from the vertex. So it goes in this order. You have the focus inside the parabola. You have the vertex that's part of the parabola. And you have the directrix, which is a line outside the parabola. No matter which way this thing is facing, because we're going to move this thing around eventually, could move to the left, it's going to be like that. Could move down like that. And off camera. The focus is going to be inside the parabola, and the directrix is going to be out this way. It's going to be this way too. Yeah, it's going to, what the heck? You know, this is not a function, but because it fails the vertical line test. But what the heck? We're going to try all of those methods. Now, this is what I want you to get out of this page, is just kind of like looking at what the picture looks like. Focus inside this curve. I want you to know why we do that even in the first place is because this is like, we use this for parabolic mirrors everywhere. How many times have you seen a satellite dish in your life? Lots. It's kind of just this basic quadratic math that worked for that. Also, we have this directrix here too. So what's the significance of the directrix? Well, just like a circle is points equidistant from a single point, each one of these points on the parabola is equidistant from the focus and from the directrix. Let's use this point, because that's you could actually see it there. This point on the parabola is 4 away from the focus and 4 away from the directrix. You can really see it there because it's orthogonic. It's like 90 degrees, right? But it's true here as well. You could use the distance formula or the Pythagorean theorem to note that this is equidistant to this. Although this one looks a little longer, I'm just going to have to trust the math on that. This is equidistant. This point is equidistant from the focus and from the directrix. Oh no, the bell's ringing. I'm still continuing. I don't care what the bell's ringing. This lesson is too important. So each one of these points is the same distance from, and these ones too. I just didn't actually graph those. Each one, in fact, you could say the parabola is an infinite collection of points, equidistant from the focus and from the directrix. In fact, I will say that. I don't care who hears me. I was about to yell it. I decided not to. And that's page 91. And I just want to say that in underneath all this, a parabola can be defined, oops, yes, as a set of points. Let's use equidistant because that makes us feel smart. It just means equal distances, but using that word will turn heads at a party, I'll tell you what. Like, oh my goodness, that person sounds smart. Equidistant, excuse me, equidistant from a fixed line, which we're calling the directrix, and a fixed point, which is called the focus. That's enough math for this page. Let's move on to page 92 when you're ready. Are you ready? Oh, good. La, 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 la. All right, I've already set up this page. You know, I knew it was coming, so I set up this page. And let me just talk for a little bit. You may need to pause the video, though. I'll tell you when you have to pause the video. But let me flap my gums for a little bit about these. So we're looking at 4 different equations that are basically 2 different equations with this added minus sign just to kind of keep it honest. Because the p-value should always be positive. Because remember, the p-value is the distance between the vertex and the focus, and also the vertex and the directrix. So we're looking for p here. We're looking for p for a lot of this. And when I look at these functions here, I have the p-value kind of set right in there. I have h and k, which in this case, hk is the vertex. As you probably would have guessed. And the p-value is the distance. So we really are just kind of setting this up here. If it opens right or left, you'll see we have these 2 equations, where the y minus k is squared. That opens right or left. If something opens up or down, the x is squared. You're actually a little more used to these ones. This is the one we just did. we would use this, where h was 0 and k was 0, and p in this case was 2. P in this case was 2. So we're going to be using this equation quite a bit. So write down these 4. Here, let me zoom out a little bit. These are the top 2. And if you want to pause the video, now would be a good time. These are the top 2 equations. These are also available in Schoology, of course. And then these are the bottom 2. And they're very similar, but I just switched the y and k, y minus k's with x minus h's. And because these are open notes tests, I would leave these somewhere handy so that you know. All right. Let's draw one here. Let's graph y minus 2, the quantity squared, equals, let's make this 4, x minus 1. I actually just kind of made that up. Hopefully this works. Otherwise, it would be ungraphable. We'll see. Can you find HK for this, please? Can you find HK, please? Okay. If you've said 1, 2, you are absolutely correct. The H value is 1. You take the opposite of the number, remember? And the K value is positive 2. So here's going to be our vertex. Now, this is going to be opening right, because, it's right there. I guess it's kind of obvious because I said right there. But the way you would tell that is you would look at this to see if it's a positive number or not, if you want to do that. And, of course, you could always put in values for x and y and get, parts of that parabola, but that's not really what this lesson is about. This lesson is about finding the focus and finding the directrix. And in order to do that, you need to find the p-value. So I'm going to compare this with this. And I made the first one a little easier. This is 4p equals 4. So we're seeing that this part, 4p, equals this part. We're kind of matching up this formula with what we actually have here on the ground. So 4p equals 4. P is going to be equal to 1. So what does that mean again? Oh, that means that the distance between the vertex of the parabola and the focus is going to be 1. So this is the vertex. This is the focus. The directrix here would be the y-axis, or, so actually, let me say the focus is 2, 2. The directrix here would be the line represented by the y-axis, which would be x equals 0. That's how you write a line. You need to have the x equals, it's not just the 0. And so it's going to be hard to do because it's right on the axis. But I'll just try to make a little dotted line here. That's that. And then basically this is going to go like this. If you want to find actual points of that, now I kind of do because that looks pretty bad, but I just want to kind of focus on this is the focus inside the parabola. This is the directrix outside the parabola. You see this opens to the right. Let's get an actual point in for that though. Like if I said, let's say x equals 2. I'm kind of curious about that. So if I put 2 in there for x, 2 minus 1 is 1 times 4. Then I'd have to solve y minus 2. I don't really like that. Forget that idea. Let me put in 3 in for y. That'd be a little easier, right? Because then I'd have to, putting in x, I'm going to have to take the square root of both sides. That sounds like a pain. It would work, but I think it'd be easier. What if I said 3 was y, right? I'll put in a y and get out an x. That sounds interesting. So 3 minus 2 is 1. 1 squared is 1. I could, at that point, divide both sides by 4. So that's 1/4. And then add 1 to it, 5/4. So 5/4, that's a hard problem. 5/4 would be here-ish. I would get out 3. So actually it's going to be a little larger. And then 5/4 1 would also be an answer because these things are symmetrical. And that's enough. I think for your delta math assignment, you don't have to kill it with the actual parabola itself. But it operates like a function. Even though this isn't a function, you can still put in values for one of them and get out values for the other one. It would have worked to put in 3 in for x2. It's a little harder to take these square root of both sides. So I put in a value in for y. So there we go. There's our focus. There's our directrix. It works the same way if a problem opens left. And you can tell that if this part is negative. Let's try this one. Now this is not in the same format, right? This has the x by itself here. This one doesn't. This one has a negative 8 times. So what we're going to do is we are going to factor out whatever's next to this x and put it out there. So I'm going to factor out a negative 8. And if I divide both of these by negative 8, that'll be x, which is what we want, because the x is by itself. And 8 divided by negative 8 is positive 1. All right, what's the vertex of this? What is the vertex of this parabola? The vertex. And I'm not sure where the parabola is yet, so I might have to erase this stuff. There's no k value there, so I'm going to assume that's 0. And that, since we factored out that negative 8, oh, that shouldn't be a minus. That should be a plus. It should be a minus, shouldn't it? No, because if I distributed that, negative 8 times x would be negative 8x. Negative 8 times negative 1 would be positive 8. I'm glad I caught that. Oh, my word. So that's going to be in a different place than I originally thought. That's going to be at 1, 0. So I'm going to draw that vertex, 1, 0. Oh my gosh, I think this is going to graph perfectly, that I don't have to move everything. That's the vertex. What's the p-value? What's the p-value? Now that we got this, in fact, you could change this to y minus 0, the quantity squared, if you were really into making this look like that, and I am, so there we go. What's the p-value? So we're comparing this, what we have, to the formula. You see how the p-value is just kind of sitting out there? So we have negative 4p equals negative 8. P equals 2. Oh, that sounds familiar. So I am going to, from this is going to open left. So from here, I'm going to move 2 this way. This is going to be the focus. And the directrix is going to be here. It looks like it's x equals 3. So here is my directrix, x equals 3. Here is my vertex. Here's my focus. And I know it's going to be some sort of, shape like that. Let me just find one point to hang my hat on here. Let's see, what should I put in? I'll put in a value in for y. How about 2 squared? I'll put in 2 for this one, because it's a little easier math. If I put in 2 squared, that would be 4. If I subtracted 8, that would be negative 4. And if I divided by negative 8, it would be 1/2. So I put in, x would be 1/2, that would be here. And y would be 2. So that's good enough for me. This is symmetrical, so I can put that point down there. Yeah, it was pretty close with my guess. So that one goes that way. That's kind of nice. Let's look at the opens up, opens down. So hey, let's do this one backwards. Can you find the formulas given the parabolas? You do more of this in delta math than anything. Let's say we had a vertex, I don't know, how about at 3, negative 2? 3, negative 2. What the heck? And you had a p-value of, let's say 3. And this looks like it's going to open up, so let's do that. We'll have the focus 3 up here at 3, 1. And that makes the directrix. I have to make the focus and the directrix equidistant from here. I mean, that's like the definition of a parabola in this context is how that works. And when we do that, here, let's just draw. Let's not kill it with the exact. Let's just draw that. All right, pause the video. Pause the video. See if you can come up with this formula. I bet you can. I bet you can. Did you pause it? Have you paused it yet? Come on, pause it. Get the right answer. All right, I'm going to give you the answer because I can't help myself. Whenever I pose a question, I got to answer it as soon as possible. The p-value here is 3. So this is 3 away, this is 3 away. So p is 3. Boop. HK, in this case, is, 3, negative 2. I'm just literally going to plug these into that formula. So this becomes x minus 3. Here, I'm going to erase this so I can write it big. The quantity x minus 3 squared equals, since p is 3, I'm just going to multiply 4 times 3, which is 12, times the quantity y plus 2. That's it. That's the formula. A lot of your delta math is going to be kind of doing this kind of stuff. They will give you a nice graph, a perfectly done graph, and you will do this. So let's do that one more time. How about this? What if I gave you the Directrix, which will make that, I don't know. How about y equals 2? Boop, 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 boop. And I'm going to give you the focus, not the vertex. I'm not giving you the vertex this time. I'm feeling stingy. I'm going to say the focus is at, let's go over to the third quadrant. How about negative 3, negative 4. This is the focus here, is negative 3, negative 4. That's all I'm giving here. I'm not giving you the vertex. Mr. Barnes, why would you do this to these kids? Well, I want them to think critically. I'm answering my own questions. Where would the vertex be? Is it somewhere on the page? Is it over here? Down here? It'd have to be halfway in between the focus and, where is it? There it is, the directrix. So what's halfway in between negative 4 and positive 2? If you said negative 1, you're right. Looks like the p-value is 3. The p-value is 3 because the focus is 3 away, and the directrix is 3 away. Next, let's just draw this parabola opening down. And I know it's opening down because the focus is this direction. The focus will be sitting inside. I always think it helps to imagine that satellite dish. Where is it in that satellite dish? Oh yeah, it's just focused right here. All these beams are going into there right there. So what would be the equation of this parabola? I'm just going to plug in what I know. Oh, I didn't put the vertex down. That's negative 3, negative 1. That's the vertex. All right, put them in. Put those values in there. I'll race you. Go. Oh, what is this? Oh, the pressure's on now. Got to get the right answer. I can do this. Let me just double check. Don't want to get this wrong. That's it. That's right, I'm pretty sure. If it's not, I'll give you some extra credit if you find the wrong answer, but I'm pretty sure that's right. That's page 92. Page 92. All right, thanks for sticking in there. That's the notes. I don't want to give you any more pages. That is intense. So if you need anything along the way, I am checking my email as much as I possibly can, you know, with remembering to hydrate and everything. So give me an email. If you need anything, if you feel stuck. Because sometimes you just need to push in the right direction to get there. And I will be that person to push you metaphorically in the right direction. Be well. See you soon.